Hello and welcome to this webinar on advanced materials and about strategic autonomy in Europe. I'm going to hand over to the chair of Eurocase, Eloy Ignacio Alvarez Pellegri, to give a few words of welcome. Eloy.
Thank you very much, Luis. Good afternoon to everybody. As president of Eurocase, I would like to welcome you all and thank you for joining us. Eurocase brings together the National Academies of Engineering, Applied Science and Technologies from across Europe, providing independent, high-level expertise to inform policy and strengthen Europe's innovation capacity. As a trusted voice in the scientific and engineering community, Eurocase promotes evidence-based advice to support strategic decision-making, in particular within SAPEA and within the scientific advice mechanism. Today, we are pleased to highlight the Advanced Materials Evidence Report Review developed within the SAPEA framework to support the group of chief scientific advisors. This report offers a comprehensive assessment of how advanced materials can drive Europe's green and digital transitions while reinforcing a strategic autonomy that is one of the topics to be dealt today. It also identifies key challenges and policy considerations to ensure responsible, safe and competitive development in its rapidly evolving field. I would like to warmly thank all experts and stakeholders for their paramount and complementary contributions throughout the evidence gathering and quality assurance processes, with a special mention to the co-chairs, Professor Ank Weidenkampf and Professor Oli Ikala, I think is here present today, and of course to the members of the working group that have worked intensively and have contributed to this report. Thank you also to the group of chief scientific advisors to be members of this meeting of today, those who are attending. Thank you again, and I pass the word. Thank you for inviting me as Eurocase, and thank you, Luis. The floor is yours. Thank you.
Thank you very much, Eloy. And moving on.
Joe, my turn.
No. So today's meeting, or today's webinar, is going to be looking at two pieces of work, as Eloy has just described. One is the SAPEA Evidence Review Report on Advanced Materials, and the other is the scientific opinion of the group of chief scientific advisors who have written policy recommendations on advanced materials. And both of those reports are available at the URL that you can see on the right-hand side. The format of today's webinar is as follows, and all of these times are in European time. So if you're in the UK, for example, this will be 1 hour earlier. We started at 2 o'clock. We're about to go into a short presentation on background and context. The panel members will make their presentations at about 10 past the hour, and that leaves about 20 minutes at the end of the webinar for discussion and Q&A with the audience. We'll wrap up and close at 3 o'clock sharp. So the chat box is open for general discussion. We do invite questions to put to the panel, but please use the Q&A box to pose your questions to the panel, not the chat. And please keep the questions short and to the point. Thank you very much. Just to introduce the speakers very quickly, we start with Oli Ikala, who's a distinguished professor at Aalto University in Finland, who was co-chair of the SAPEA Working Group on Advanced Materials. He will be followed by Rafał Lukasic, who is a member of the Group of Chief Scientific Advisors. He's director of the Research and Innovation Department at the Lukasiewicz Center in Poland. Andrew Barry is Chair in Human Geography at the University College London and was a member of the SAPEA Working Group on Advanced Materials. And finally, we will hear from Nicole Grobert, who's Professor of Nanomaterials at the University of Oxford and is also Chair of the Oxford Advanced Materials Network. Just to say that the speakers are free to say whatever they would like during the webinar, and any views or opinions that they express are theirs and may or may not reflect those of the EU or the European Commission. So we start with some background and context as to how we arrived at the two reports that we've shown you earlier. And for that, we welcome Dr. Geoffroy Delamere, who works for the SAM Secretariat at the European Commission. Geoffroy, over to you.
Thank you very much, Louise, and thank you to everyone attending this webinar. So just a few words about the scientific advice mechanism. We provide scientific advice to the College of Commissioners, and the scientific advice mechanisms, or SAM, is composed of three parts. There is a group of chief scientific advisors, which are appointed by the Commissioner for Research and Innovation, and which is a group of 7 highly qualified scientists. There is also SAPEA, which is a consortium of academy networks, and you just heard words from Eurocase. And there is also the SAM Secretariat, which is a unit within DGRTD of the European Commission, and which I am part of. And this scientific advice mechanism provides the interface between the scientific community and the European Commission. So a few words about the advisors. So as I said, they are a group of 7 experts, which cover a broad range of academic disciplines and also geographic location. And present here is Rafa Lukasik, as Louise just said. The SAM Secretariat, so we are a small team within the European Commission, and we act as a liaison between the SAM and the Commission. We coordinate the scoping paper development, meaning that we discuss with the policy units responsible, or like who is interested in the scientific question, and we coordinate the scoping question with them. We support the advisors, and we also coordinate with SAPEA to provide the scientific evidence. And importantly, we analyze the policy landscape, which is both European and international policy landscape, to make sure that the scientific recommendation will land well into the context of the European Commission policy landscape. And about SAPEA, so SAPEA is a Horizon Europe funded project, and it is a consortium of academy networks, and they can reach out to more than 120 academies all across Europe. So when we receive a request for scientific opinion, we call SAPEA, and SAPEA will launch search for expertise across these academies, and then they will form a working group depending on the experts that are relevant for the question. And they work independently from the Commission, which is quite important. They have their own internal process, and their work is also peer-reviewed. So to summarize a bit how the scientific advice mechanism works, first we receive a request that we again receive from policy units in the European Commission. We review the evidence. So this is the work of SAPEA that set up the working group to provide an evidence review report. And then we make recommendations. So this is where the chief scientific advisors have a role. They will take on the evidence review report, and they will put this in perspective with the policy landscape to develop their own scientific recommendations. And at the end of the day, we deliver our advice, and we had the handover of the scientific opinion and evidence review report to Commissioner Zaharyeva in April. And regarding this particular request on advanced materials, so this is a request we received from the Commissioner in charge of Research and Innovation, Commissioner Ekaterina Zaharyeva, and we received this request in April last year. And the 2 main questions that you can also find in the scoping paper are what contribution can advanced materials bring to the EU's strategic autonomy, and how can the cross-fertilization of innovation in this sector can be enhanced. And both of these questions are aimed to inform the Advanced Materials Act, which is due to be proposed by the Commission by Q4 of this year. And yeah, that's it on my side.
Thank you very much, Geoffroy. And we now move to the panel. And our first speaker is Olli Ikola, who was a co-chair of the SAPEA working group on advanced materials. Olli, over to you.
Thank you. As said, I am Olli Ikola from Helsinki Aalto University, and my field is soft matter, and I was co-chairing the evidence review report together with Professor Anke Weidenkauf, who is a metallurgist and so-called hard materials and ceramics. So I think we made a kind of balanced mix of co-chairing the all sides of advanced materials. So we started to collect the working group. So we got more than 100 candidates, and we selected 22 experts, and they were in widely different terms of discipline, country, and career stage. And we tried to select the experts so that they are not promoting their own individual fields, but they are as a generic experts for the whole field. And I think we managed rather well in that. There were rather good discussions and different opinions, and these were as a basis of the evidence review report. So altogether, we had 6 meetings in the working group, starting from the scoping paper as described previously, and we were given a few more specific details also on the topics to pay some attention to energy, health, mobility, electronics, and data science. So we had a very strong support from SAPEA to write on this report. We had several meetings on site, but let's say mostly we were working remotely. So we had the final version mid-December, and we had also discussions with industry to have industrial views. So the structure of the report consists of 7 chapters. We first describe the introduction of what are advanced materials, and we really encountered the problem how to define advanced materials in relation to generic material science. And we made a selection that we didn't describe advanced materials in a very detailed manner, because there can be rapid inventions which completely change the landscape. Therefore, we kept our focus in generalities. An example how very abrupt changes could change the total landscape is the 2D materials, which were found something like 15 years ago, which totally changed the landscape of the nanotechnology. So the chapter 2 was dealing sustainability and concepts and processes and best practices. Then chapter 3 described general principles of manufacturing and also scaling and infrastructure. Then we described in the next chapter the needs for basic research, and then next chapter digitalization, which turns out to be extremely important for the next generation of advanced materials. And then chapter 6 was dealing policy legislations. And then the final chapter is overall conclusion and suggestions for policy options which were um, given for a basis for the more detailed policy options. So, as said, chapter 2 was on sustainability, and this is probably one of the most important chapter in relation of the European resiliency. So Europe is rather vulnerable in relation of some rare minerals. It turns out to be a socially challenging option to increase substantially mining of these critical rare materials. And it turns out that one option to overcome this is to increase recirculation. A particular option is the electronic waste, because electronics components, they contain a substantial amount of these rare materials which are there in the catalytic and some amounts, also lithium and cobalt. But there's a challenge to use recirculation, because in the industry one needs to have a kind of homogenized raw material source. So having recirculation requires several scientific concepts to be able to scale up for wide scale industry. Then another point related to strategic autonomy is related to oil. The future advanced materials are partly more complex, because they need to have a combination of different properties, which divides the systems with single materials like the classic, for example, polyethylene or polymers. And so this complexity of the materials also leads us towards more bio-based materials. This allows Europe to concentrate on so-called synthetic biology to overcome the excessive use of oil. But also that requires quite much research to allow the scalability and energy efficiency. But the basic toolbox is existing. This all requires Europe to behave as a unified entity against the high competition against America and China. Then let's take the chapter 3, which was dealing on the emerging technologies. So there, one of the problems in Europe is a scattered ecosystem, and we need to have a kind of common so-called sandboxes to able to have the piloting of the materials over the Europe. We also need digitalization of advanced materials, because, as I said, very many of the emerging advanced materials are multi-component and complex. One of the problem in Europe, as we all know, is the scaling. And the scaling problems and challenges can be solved by improved combined pan-European approaches. But there still remains problems in relation of funding and risks, and also the standardizations and legislations, which will be described later. And I think Professor Barry will be describing it more in detail. So the chapter 4 deals basic research. The future advanced materials are emergingly require more optimization and conceptual findings, and this requires basic research. So we strongly emphasize that the basic research is strongly coupled for the applications, and so a strong basic funding platform in Europe, like the ERC and the other funding sources, they promote very much on the prosperity of advanced materials in Europe. And we strongly emphasize that this should be kept at a high standard. The chapter 5 discussed digitalization, and there are two facts related to digitalization. On the other hand, there's the simulation, and on the other hand, it is the data libraries, and they go hand on hand. So one of the problems in data libraries deals that it is difficult to check the validity of the data in the data libraries, and it there needs to develop curation platforms to validate the data. And one of these approaches could be to combine simulation and experimental data to have a kind of mutual curation. What is a great problem here, or challenge, is that as we all know, very much of the data-driven concepts have been slipping out of Europe, in the US and in China. So we have to be very careful that we keep the materials related digital data and data libraries in Europe to boost the European science. So the chapter 6 relates to policy. I just skip this over because I guess Andrew Berry is going to be describing it more. But one of the most important points is that we need to be very careful in the legislation. On the other hand, we strongly need new standards, for example, for the new construction materials, which would be useful to reduce the carbon dioxide emission. These construction materials can't emerge to the market without a good standards. But on the other hand, we have to be very careful not to have over legislation, in which case the important findings would be slipping to China or USA. So I think this is roughly the scope of the evidence review report, and I would be happy to answer questions in the forthcoming discussions. Thank you.
Thank you, Olli. And moving on to Rafał Lukasic next.
Hello, good afternoon. Good afternoon, everyone. Thank you very much for opportunity to speak to you today. My short intervention will focus on the role of advanced material in strengthening Europe's strategic autonomy, and the presentation I'm referring to is based on an evidence review and scientific opinion prepared for the European Commission, with a handover to Commissioner Zacharieva in April this year. Next slide, please. So let me start with the challenge. So we know that Europe needs advanced material to deliver on several major priorities at once: the green transition, digital leadership, industrial competitiveness, health innovation, defense resilience, and reduce dependency on global supply chains. So the challenge is not only to invent new material, but actually the challenge is much bigger, is to move from excellence research that we have in Europe to reliable, safe, sustainable, and scalable options. This means that Europe needs a coherent vision. Advanced materials should support strategic independence, but not in a narrow or defensive sense. Autonomy should mean the capacity to act, to design, produce, assess, and deploy key materials in line European values and long-term public interest. Next slide, please. So the vision actually is quite clear, at least for us, because as we know, Europe should become stronger in advanced material by combining scientific excellence, as I said already, industrial uptake, safety by design, sustainability by design, and market readiness. This is especially important because many advanced materials have novel properties, novel functionalities. These properties create opportunities, but they may also create uncertainties. We therefore need to assess materials not only at the final stage of the product, but throughout the full innovation pathway, from discovery and design through manufacturing, use, recycling, and the end of the life. So safety and sustainability should not be seen as a barrier to innovation. Actually, they are conditions for public trust, regulatory acceptance, and market success. Next slide, please. So we know that importance of advanced material becomes very concrete when we look at applications. In healthcare, biomaterials can support improved tissue regeneration and more effective therapies. In electronics, quantum materials can enable new generation of devices and communication technologies. In mobility, composites can reduce the weight of vehicles and improve energy efficiency. In aerospace, advanced ceramic can support high performance and efficiency of systems. These examples show that advanced materials are enabling technologies. They are not limited to one sector. This is why Europe cannot treat advanced material as a fragmented topic. So the key question is not only can we discover promising material, but the question actually that we should ask ourselves is can we develop them responsibly, scale them efficiently, and bring them to the market in Europe. Next slide, please. So as a group of scientific advisors to the European Commission, we propose the set of recommendations. There are 4 main recommendations. The first recommendation is to support the creation of data space for advanced material. This includes FAIR plus data, as well as digitalization, artificial intelligence, and computational methods. This tool can accelerate materials discovery and reduce time from research to application. The second recommendation is to design standards that support safety and sustainability at every level of technology development. Standards are essential because they create trust. They help innovators understand requirements, support regulatory clarity, and make it easier for companies to access the markets. The third recommendation is actually to strengthen ecosystem that help advanced material move from R&D curiosity to industrial uptake. Europe already has excellent research, as we know very well, but excellence alone is not enough. We need coordination, testing facilities, scale-up capacity, and links, especially between research and industry, to speed up this uptake. The fourth recommendation is to invest in Europe's strength in advanced material research and innovation. This means sustain investment not only individual project, but in capabilities, infrastructure, skills, especially skills, interdisciplinary teams, and long-term strategic areas. So together, these recommendations point to one central conclusion. Europe should not separate scientific ambition from policy ambition. Next slide, please. So for us, the 3 key words here are autonomy, sustainability, and prosperity. Autonomy means having the capability to develop and deploy critical materials and technologies. Sustainability means ensuring that these materials are safe, circular, and environmentally responsible. Prosperity means turning scientific and technological excellence into industrial values, jobs, and social benefits. So for Europe, the opportunity is to position advanced material as a strategic pillar of future competitiveness. Next slide, please. So let me close with one final point. Advanced materials require scientific depth, but also policy coordination and public responsibility. So that's why advisors work behind this opinion, brought together expertise from different areas that you can see, and we believe that this interdisciplinary perspective is essential also when we are talking about advanced material. So if we want that Europe wants advanced material to serve strategic autonomy, we must develop them not only faster, but also better, safer, more sustainable, more scalable, and more aligned with European values. Thank you very much.
Thank you, Rafa. And we move on now to Andrew Barry, who is a member of the SAPEA working group and at UCL. Andrew.
Thanks so much. And thanks so much to Ollie and Rafa. You really kind of covered a lot of ground, which I think intersects with what I'm going to talk about. It's a hugely rich report because there's so many different kinds of important advanced materials to address. And I think, Raphael, you put your finger on it and saying, how does one create a coherence out of this kind of apparently kind of very fragmented landscape, which cuts across so many different sectors? So if you'll forgive me, I'm going to focus on actually just at the beginning of the report on the question of the definition, which I think does need to be returned to. Next slide, please. I don't expect you to read these, are much too small. There is a working description from the OECD from 2023, which we used as the starting point for a slightly more elaborated and hopefully nuanced account of what advanced materials are. But I want to give my own gloss on this and perhaps kind of slightly redirect the conversation, drawing upon our own work, but also adding something more. Next slide, please. If we look at the OECD definition, or actually it's not called a definition, it's called a working description. It suggests that advanced materials are defined by new and enhanced properties and enhanced structural features. And one can think of all kinds of new and enhanced properties which advanced materials may have. But it strikes me that here, this is in some ways quite narrow, if like technical definition of what advanced materials in terms of properties, rather than understanding the kind of broader strategic kinds of questions which Rafael has introduced. This is from the OECD. I think our report really extends this in interesting ways. So I want to kind of bring out what I take to be a kind of a more developed account of advanced materials without suggesting a different definition. Next slide, please. First of all, I think we have to say, and although I'm a human geographer, I originally studied natural sciences, including materials science as an undergraduate. Advanced materials is more than a scientific concept. It's a kind of hybrid policy, political, and scientific concept. Clearly, whether a material is advanced or not depends upon what and for whom the material is advanced for. And different materials may be advanced in different ways for different users or groups. So the question of whether a material is advanced is, I would say, a socioeconomic as well as a technical question, and one needs to think about it in both those terms at once. Crucially, and this is mentioned by the OECD and as well as discussed in our report, what counts as advanced clearly changes over time, but it also varies geographically. A advanced device, measuring device, which might be useful in Silicon Valley or MIT or Cambridge, may not be useful in a country which doesn't have the same infrastructure to support that. And indeed, even in the report, we recognize that traditional materials in principle may still have certain kinds of advanced properties. It's mentioned, for example, self-healing cement used in the Pantheon in ancient Rome. So it's a kind of rather more complex question than just focusing on technical properties. Crucially, and I think this is really central to the report, and is that advanced materials are more than material. They are supplemented and enhanced, and they're designed through the development of multiple forms of information about their properties. And the range of properties which we're interested in has certainly increased. And Rafael and Ollie have mentioned sustainability as rather crucial. We know we can use them in the ways which are intelligent because we know more of what their properties are. And it's a concept I've used. It's not one used in the report. I would say it's quite useful to think of materials as informed materials, increasingly informationally enriched materials, and that kind of bringing together of multiple sources of information and the material is absolutely crucial to understanding what a material is. It's not merely a philosophical question. It has important practical implications in terms of where one derives information and its reliability and so forth. Crucially, and I think this is really, Ollie and Raphael have both emphasized this, a concern with sustainability, safety, toxicity, crucially resource scarcity in the context of the green and the digital transition and the environmental impact has become crucial to the design of materials. So we're talking about particular properties which need to be added to, if you like, let's say traditional properties like strength or kind of conductivity or whatever. And these need to be addressed throughout their life cycle and have become central to the design of what I would dare say called specifically European advanced materials. If you like, this is advanced materials with a kind of European texture. Hence the focus on repair, self-healing, the circular economy and so forth, and many other related concepts in the report. So we're both informationally enhancing those materials, but informationally enhancing those materials in a particular way, which recognizes both the environmental impact of material use, but also the particular strategic position of Europe. Next slide, please. Now, Ollie has already said that one of the features of materials is if they of such materials as they can be thought of as part of systems or assemblages. They're not kind of individual things like iron or particular synthetic polymers. That's the combinations that matter. But at the same time, individual advanced materials, I think, take multiple forms, and this is a kind of key challenge in thinking about the development of advanced materials, if you like, from lab to product. The advanced material that one encounters in the lab may be quite different from, or similar but different from the way it performs in a computer simulation, or for that matter in the factory or in the home, where users may use the material in a rather different way. Think of the use of hazardous substances in the home, which may not follow necessarily manufacturers' instructions, and indeed in the environment after their use. And the design is increasingly information-based, integrating AI modeling and so forth. And so the crucial challenge, which standards play a really important role, is to translate between these multiple forms of existence of materials. Materials are both informed, but they're also multiple in their forms of existence. And that poses challenges as one moves from lab to model to point of manufacture. This makes, and this is just emphasizing what Raphael and Ollie have already said, this makes the question of the quality, the accessibility, the interoperability, the reliability of data critical to their design. I mean, it's a kind of critical issue in the age of AI, what the kind of the data which goes into the model is. If you put bad data in, you will get slop out. And so actually, that is something which, again, I think Europe can play a kind of crucial role, if you like, in designing good materials and designing materials which meet public expectations of safety and lack of toxicity and so forth. And both those things, as Raphael has said, go in hand. Good innovation should not be sort of in tension with questions about with public accountability. So I'd emphasize that as well. Next slide, please. So I want to conclude by perhaps rather controversially saying that advanced materials actually perhaps are not just a set of substances in the first place. There are many identifiable advanced materials, and the report has interesting things to say about them. But the way that I've presented it here, I think advanced materials can be thought of as a kind of a modulation of a paradigm, a research development and innovation paradigm, which can be formulated in specifically European terms, given the demands of European consumers and industry for quality and for sustainability, but also because of the lack of access to resources. And this paradigm, if you like, builds into the design of materials concerns with sustainability, resource scarcity, toxicity, and safety over the whole life cycle, and makes use of expanded range of sources of information, triangulating across many different sources of information, from public data and AI and machine learning, and from public deliberation too, where appropriate. And it strikes me that one needs to emphasize, but also reinforce, support with appropriate financial and regulatory measures, these European strengths in public, reliable data, in accountability, and so forth. And this formulated in this way, I think the concept of advanced materials more clearly kind of relates, as draws out what Ollie and Raphael have said, which is that advanced materials in their definition have a kind of intrinsic relation to Europe's strategic economic autonomy. And that's crucial, while also reducing the impact of this economy on communities and the environment within and beyond Europe. Because as we're increasingly realizing, as economies rightly address the question of climate change, that the green transition itself has its environmental and social impact in terms of the toxicity of waste associated with expansion of mining and so forth. And that needs to be addressed as well. So it's, if you like, a kind of increasing the economy, the strategic autonomy of Europe from all of the challenges, or certainly some of the challenges of an economy which is overly based on extraction as its main model of acquiring materials. Okay, I'll end there. Thank you very much.
Thank you very much, Andrew. That's the end of the slides. So I'll stop sharing and hand over to Nicole Grobert as the final member of the panel. Nicole. Nicole,
you're muted.
You are muted, Nicole.
It's the usual. Sorry. So thank you very much. Thank you also, Ollie, Andrew, and Rafal for your interventions. I'm here today. I speak personally. I'm a material scientist. I work at the Department of Materials at the University of Oxford. But of course, reflecting on what we heard, I also draw from my experience as the former chair of the group of chief scientific advisors, and the scoping paper the group received just a month before I departed. So I'm very pleased to see now the output, the scientific opinion and the ERR. Now, the observation that I had from these documents, my own experience as a material scientist, but also the presentations we heard, we know Europe has world-class material science and it's world leading in safety regulation. We're brilliant at discovery and we're brilliant at setting standards. What we have to become now is we have to become brilliant at sort of turning ideas into products and startup into scale-ups. And one point that has not been mentioned is failure into learning. That's a positive paradox that I see. And the question is how to do it. There's the strategic autonomy, it's the title of this webinar, and the scientific opinion puts it actually quite well, I think. Autonomy, what does it really mean? It means controlling design, data, and circularity. And it doesn't mean to close our borders, but it means to open up to our strengths. And I'm going to throw a bomb now, Andrew's definition about advanced materials. Personally, I would say is to put the emphasis on materials. Do not only focus on advanced materials, but focus on materials as a whole, from smarter steels to biomaterials, recycled concrete. That will power our circular economy. A circular economy doesn't really care about labels. It cares about properties, safety, and recyclability. And that's actually a huge opportunity for European innovation. And what is equally important is the cross-fertilization of innovation. This is where Europe, in my view, can really lead. And here, especially in supporting startups. Startups are our future. The problem today is they face too many obstacles. They face two main obstacles, and we can solve that together. It's basically looking at complex rules and shy capital. I think one of the attendees commented also on the standards. Don't make it overcomplicated, but make it accessible for sort of innovation. On the rules, so we can create a single digital gateway, for example, for regulatory information, fast track certification for SMEs, and also harmonize standards across member states. And what we must not do, though, is to lower safety. We never even think about it, but make compliance proportionate, clear, and cross-border. You just need to imagine a startup trying to start a startup where you have some amazing idea, but then you spend your time on forms. So what you really want to have is a startup spending its time on the science, not on the forms, and that must be possible, and it is possible. Regarding the capital, European venture capital in deep tech is growing. That's good news, but we need to have capital that is patient, long-term, sort of long-term investment, public and private, and investment must understand that material startups take years, not months. And where we really need a total cultural shift, and that's I'm quite most optimistic about, is that we are learning that failure is not the end. In Europe, we have sometimes treated failed startups as a closed chapter, but the best innovation ecosystems see failure as a stepping stone and a source of experience and resilience and smarter next tries. We're already seeing more second chance funding, more mentorship for restarting founders. And I think we should accelerate that. Let us build a culture where a founder can say, oh, I learned, yeah. And the investor says, okay, try again. Obviously, blue skies research, that's in my personal view, the engine of it all. There is no applied research without any fundamental research, and there are no products without the ideas. Now, I'm a passionate believer in curiosity-driven science, but I also believe that it cannot entirely rest on the ERC alone. Blue skies research must exist beyond the ERC, in national programs, in Horizon Europe, in university institutes, because the next perovskite or the next self-healing material may come from a small lab with no access to flagship funding because you just haven't got the connections, but you have the one big idea. So let us spread the freedom to explore across the whole research landscape that blue skies research is present. And let us build a sort of a gentle and respectful bridge between that fundamental research and industry. It shouldn't be a top-down direction, but it should be a genuine dialogue. You should not end up as doing the research directed by industry, but real researchers should be learning about real-world challenges, and engineers or employees of industries should be learning about frontier science, what's state of the art. And that is what I mean is true cross-fertilization at its best. Now, from the scientific opinion, there are actually 3 practical steps that give me a lot of hope in this direction. So one is there's a proposal on open access pilot lines of these shared facilities where any startup can test scale up without building its own factory. That's a good one. Also, the public procurement as a first buyer, Europe could use its purchasing power to create early markets for sustainable materials in energy, health, mobility, infrastructure, and the list is long. And thirdly, shared AI-ready European materials commons is quite important. A federated data infrastructure alongside first-class materials research facilities, because you need real data to feed AI, that makes us then the fastest place on Earth to design and validate any new materials. Now, in conclusion, the paradox I started with is not really a dead end. I think it's a real opportunity. It's a starting line. Europe has the science. Europe has the values. Now we just have the chance to add 2 more strengths, and that is smart, simple rules and a culture that learns from every attempt. And on a personal thought, I'd like to add, and now I can say that because I don't have to strictly adhere to the scoping questions. It's important that the Advanced Materials Act does not only look at advanced materials in isolation, but policymakers need to keep advanced, or materials, I should say, in the back of their minds in general whenever establishing new policy in the wider context. As materials are the core of our lives, everything that is surrounding us are materials, and they're directly linked to addressing climate change, the most pressing challenge society is facing. So let's build a Europe where a materials startup can take a bold risk, get patients backing, navigate clear rules, and if it fails, stand up and learn, and if it succeeds, scale up, create jobs, and lead the world from Europe. And I don't think that's just a dream, that's a choice, and I think we can do it. Thank you very much.
Thank you, Nicole. We have 10 minutes for Q&A. First question is from Monica, which I'm going to widen out slightly. She's talking about overseas territories of countries like the Netherlands and whether we could partner with them in the area of advanced materials. But I'm going to ask more broadly about global partnerships and whether members of the panel would think that global partnerships are a good idea, very broadly. Would anyone like to answer that? Or indeed, Monica's direct question about overseas territories, for example. Ollie, do you have a view on that? Start with you. You're on mute.
So for my side, that would be the absolute necessity. As I said, we should kind of, let's say, treat Europe as an entity, because we can't compete with China and UK. But I really don't know how this kind of, let's say, how the borders can be crossed more efficiently between the different nations. But we should find something. So,
Thank you. Rafa, do you have a view on this?
Well, I agree with Ollie. The point is that I think we are talking about a little bit higher level than so it's difficult to define whether it's for overseas territories, because this kind of the implementation, actually the recommendation that we have, that recommendations that we produce, the implementation of this kind of work will be is on the European Commission side, and of course I believe all the mechanism, all the instruments that are proposed will be seen also from the perspective of overseas. So I believe it will also happen. Yeah.
Andrew, any views?
Well, it's too general a question to answer in a way, but I would say that the geography of all materials have different geographies. I'm a geographer, I would say that actually, and these do not correspond to the boundaries of Europe. So there will be different ways in which different advanced materials require different kinds of connections with across the world, with researchers, with companies and so forth. There isn't the kind of general answer. One must be open to that possibility, I would say.
Thank you. And Nicole?
Yeah, I think research doesn't know borders in theory. It very much depends on the material system, probably, how it will be affected in terms of information exchange. But research-wise, collaboration should be global.
Monica, you have a question about AI and data governance, and I'm going to encourage you to come to our next webinar, which is on the 1st of July. So sign up for that, because that is on AI and advanced materials. The next question is from David Peck, and I encourage members of the panel to have a look at this, because I'm not entirely certain what David is referring to, but perhaps somebody from the panel can interpret what this means. Strategic autonomy in the context of the EU, not Europe. EU critical raw materials, not material scarcity, is the core example. Are there other definitions of strategic autonomy, advanced materials, and CRM used in the group. Andrew, I'm going to start with you on this one. If you could maybe interpret what you think that means.
Sorry, it's a really difficult question. I would say it remains. We didn't operate with a definition of strategic autonomy. Indeed, I think, given what I've said, I would suggest that actually what strategic autonomy means needs to be rethought in relation to the question of materials. So, yeah, this is a concept which needs to be, redefined and rethought. Different materials will make different demands on strategic autonomy.
Thank you. And given that we're running out of time, I'll move on to Jose. To what extent can Europe realistically strengthen its autonomy if research investment advances faster than supply chain resilience, given that cutting-edge innovation still depends on stable access to critical raw materials controlled by external actors? Andrew, come back to you on that to start. Any response on that one?
I think I'll pass that to Nicole, who probably has a better.
Okay, Nicole.
I'm just digesting the question, so I'm just reading it again. If faster than supply chains resilient, given.
Maybe you can step in.
Maybe you can step in,
Well,
Rafael,
of course,
actually.
that's a good point. It's a very good point, of course, but we have to do all things together. Yeah, we cannot. We have to do the things in parallel, and we have to invest in research. But one of the recommendations that we have is to speed up the process of going from low TRL to high TRL, having in mind, of course, all the aspects related to sustainability, safety, and also certification. As this builds trust, yes, for the industry to advance with this kind of materials that we want to apply because of the functionalities in some processes. So. One of the point is, as it's written here, also it's about critical raw materials. Of course, it's important to see to what extent we can, with different circularity by design, of course, sustainability by design, also see to what extent we can limit ourselves, limit our dependence on this raw materials. So many things are happening in the same time, in parallel. But definitively, we have to speed up, go from only excellent research, and move forwards to innovation and bring the products to the market faster, having in mind all the relevant aspects.
I mean, can I just add in here that I think, one thing which we didn't discuss in the context of the working group, but it's striking how rapidly the process of innovation, of course, was in vaccines was achieved during COVID. And this was done in parallel with tests of safety and so forth. That actually there may be something to be learned here in bringing these processes in parallel, which are often done in a linear way. And I very much go along with Nicole's observations earlier. We shouldn't think of a kind of linear model of innovation from blue skies to product. Actually, it's about kind of creating kind of increasing cross-fertilization and dialogues, but across the whole chain, and with users and consumers as well. But I think that was, of course, that was done in a way with the COVID vaccine development in an extraordinary way.
I think that one of the things which was very good in the vaccine was the information. The industry and science had a kind of, let's say, very efficient communication. So basically, I think that what could be done in Europe is to promote the information between the industry and science more, and have a little bit more trust, and to expose what are the real needs from the industry, and promote the discussion, because then there could happen similar things as a development of vaccination.
Okay, thanks. Alessandro, I'm going to encourage you to sign up for the next webinar on AI and innovation on the 1st of July. And we will finish with Catherine's question. Have you considered how, underlined, to accelerate advanced materials research? So how would you accelerate advanced materials research? Nice broad question there. Who'd like to start with that one?
Perhaps I can add to this one, because it actually also ties in with the previous question about the raw material supply. It's through these interconnected research infrastructures and really cross-fertilization across sort of across the length scales, supply chains, as well as subjects. So I guess the COVID vaccine was brought as an example, really creating an ecosystem where you cross-benefit from advancements and looking for alternatives to raw materials, for example. That makes sense. Rafael, you may have more.
Yeah, over to you, Rafa.
Yeah, actually, in the as time is flying very fast, we don't have much time to explain this, but I recommend you to go directly to the recommendations that we propose, and because there are some particular information, what kind of advance in this in terms of speeding up the research can be implemented. So I think you will find all the information that you are looking for, at least some of them, over there. So I hope this will be a good point for you to get know better that what was done by SAPEA, but also by us as scientific advisors.
And Oli, final word to you if you want to just say a couple of things on this one. Yes. No. Right. It is 3 o'clock European time. So at that point, I'm going to close the webinar. Thank everyone for coming. Thank you to our panel who were tremendous. And we'll look forward to seeing you at the next webinar, which is on AI and advanced materials on the 1st of July. Thank you all very much indeed. Thank you. Bye-bye.
Thank
Thank you.
you. Thank you to all. Bye.
Bye bye.